9.4 is going to look at domain and range of inverses, looking at the function and how to get domain and range. So just looking at our original function gives us the domain of it. We look for denominators, and if there's x's there, x is in the denominator, so like x plus 3 like that, we're going to have something interrupting our domain. And you just do this equals 0 and solve it to get that number. If it's none, then you just do infinities. Range. The range of the original function comes from the inverse. So if the inverse had this, and we do equals 0, you solve it and you get -1, that would be our range. And then if you get another fraction and have this as another answer, that's just how you write it if there's 2 x's that you get. So let's take a look at these. These are the 2 example problems we had from earlier. And I've already done the work for you. This is the original and the inverse. So original, inverse, and we're just looking at the domain and range of the original. So domain comes from the original, inverse gives us the range of the original. So we have a denominator here, n plus 1, and we say equals 0, we solve it, subtract the 1, we get n equals -1, but that's not our answer, we got to put it in domain. That is our domain. For inverse, we have another denominator here with an n minus 2 equals 0, solve it, so n equals 2. That goes in our range of our original function. Okay, and that is it. If we want the inverse, they switch. So the inverse would mean the domain of our inverse function would be that one. Okay, problem number 2. If you look at our denominator here, there's no x's, which means there's no zeros, which means our domain is uninterrupted. Okay, so no x's, always infinities. Our inverse function, if you notice, we didn't end up with any x's either. So no x's means we have no zeros, and our range is uninterrupted. And again, if we were looking for the domain and range of the inverse, D and R just switch. So pretty easy to find those.